In this story, the two chemist hikers decided to experiment with one of their favorite pound cake recipes. They were told atmospheric pressure decreases as elevation increases, so they decided to explore the possibility of adding soda to their cake mixture at their friend's home at top of a mountain.
How are we ever going to make this cake at such a high elevation? I'm only familiar with exothermic reactions at sea level.
Wow, when is Cindy and Marcy going to get here? I've been waiting all day. I want to explain to them the chemical changes and procedures that occur when baking a cake with 7-up atop of this mountain.
Well, Jared knows, and I bet that he has a thorough explanation of why it is useful to add 7-up to our favorite cake of this mountain abode.
You're right. So long as we have our sodium bicarbonate, our carbon dioxide, our hydrogenated oils, our protein glutens, and our sucrose, we should be fine.
Hey!
Hey guys, you guys finally made it. Welcome. Let's get started in my kitchen over here. You guys brought the ingredients, right?
Yes, we have everything except the heat source and the aluminum baking dish you told us about.
Alright, great. I think the first step to do is to mix all our properly dry measured ingredients.
Wait, I have been wondering why you asked us to bring the extra carbon dioxide, our 7-up. Does it have something to do with the fluffiness of the cake?
Well, yes it does. It helps to form tiny pockets of air in the batter, which increases the volume of the batter twofold, and it also helps to make the batter rise during the endothermic process within the oven. These carbon dioxide bubbles help make the cake light and airy, especially up here where the moisture in the cake evaporates earlier because of the higher altitude. The baking powder does not provide sufficient carbon dioxide bubbles alone.
Oh, I heard that the boiling point at higher elevation drops 2 degrees Fahrenheit for every 1,000 feet.
Yes, this is true. And as you know, we are 5,000 feet above sea level, so we drop 10 degrees Fahrenheit in terms of boiling points up here.
Put all the dry chemicals together, creating a heterogeneous compound. First, I'm going to start off with 3 cups of flour, which is going to be our protein gluten. I want to measure this properly. Okay. 1 and 3. Now I'm going to get the baking powder, which is going to be our combination of our sodium bicarbonate and our monocalcium phosphate. And here is our baking powder. Okay. And now for our sugar. There you go.
Okay, I'm going to mix our chemical ingredients that are wet here for our cake. This here is our 1.5 cups of shortening that I have softened, and then we're going to add our hydrogenated oils. I think we need about 1/4 cup of the oil with our shortening, also a hydrogenated oil. We're going to add our eggs, which are our structural proteins. We need 4 of those. 1, 2, 3, and 4. Then, for a little flavoring, we're going to add our 4-hydroxy-3-methyloxybenzolaldehyde, which is also known as vanilla extract. And of course, our secret ingredient, a little extra carbon dioxide. We'll just estimate about half of a can.
I'm glad we have so far to travel because shortening our hydrogenated fat is closer to room temperature, and this makes this batter so much creamier in texture. The sugar crystals are sharp and will cut through the shortening, thus doubling the batter volume.
Now we want to take our liquid and our dry compounds and combine them to form a creamy, homogeneous liquid. This mixing, will you mix it? Yeah. This mixing will cause the baking powder and the 7-up to effervesce. and will release some carbon dioxide, hence the need for our 7-up here at this elevation.
Don't the eggs change the structure of the batter too?
Yes, the eggs add to the volume of the cake once the proteins of the eggs have been exposed to heat in the oven. This endothermic reaction allows the cake batter to undergo a major chemical change.
All right, now for the magic of transforming a liquid to a solid using a lower temperature at a higher elevation.
I'm going to place the batter into our air circulating aluminum convection pan to optimize the distribution of heat and conduction, resulting in an even texture of our cake. Looking pretty good.
Hey, we've got a whole 35 minutes to waste. Let's go for another hike. Let's go. Wow, I cannot believe this cake rose so quickly. Look, Cindy, the 7-Up is so useful in this recipe. Check it out.
Wow, it turned out really nice. Okay, let me get this right. The batter heated up in the pan, the carbon dioxide bubbles helped the batter rise, then the steam evaporated and the protein glutens then helped shape the mold of our solid.
This is correct! You have done it! You have made very few errors. However, discuss the exothermic process before you take a bite.
Eureka! As the solid cools quickly at this elevation, there is a release of heat caused by an exothermic reaction, and our cake looks mountainous and spongy.
A success! Manger!
The end!
Ta-da! I gotta hit the lab.
Yeah.
Gotta get that extra credit point. I need it every week, buddy. I got Jared's.
Great! Our first step will be to mix. Oh, okay.
You're right.
Cut.
What?
I turned to smile at the camera.
Dork?
Awesome! A success! Manger!